Okay, good morning class. So today we're looking at quadratic equations and inequalities. We had exercise maximum and minimum value. Okay, so I know I've explained to you this on Friday already, correct? But I just need to do this so that we can have the necessary recording. Okay. So this is exercise 2.5, no? So check there, which exercise was it? 2.5, and it was on page, where it is on page? 29. Alright. So here we are told that every trinomial ax squared plus bx plus c equals 0, where a can't be equal to 0, has a maximum or a minimum value. Remember that this is a quadratic graph. But remember last year we drew the graphs. Y is equal to ax squared plus q. Not so. When a was greater than 0, when a was positive, we said the graph was smiling. And when a was less than 0, we said the graph is sad. Okay. Also, this is what we call a minimum turning point or a minimum value. The graph has a minimum value, while this has a maximum value. And this value was dependent on parameters around that equation. Not so. So it is possible to determine the maximum and minimum value by completing the square and writing the trinomial in the form of ax squared plus a into x plus q squared plus q. Okay, and this is the completing of the square format. Not so. So the question says write down the maximum and minimum value of each of the following. Now there's one of two ways of doing this. Well, probably more than that, okay. I normally use a graph, but the textbook uses the fact that if you look at x plus 1 and I squared it, then whatever x is, just choose a number for x. Any number. 5, nice. 5 plus 1 is? 6. 6 plus 6 squared is? 36. Alright, just keep that in mind. Choose another number, a negative number. Minus 3, nice. Minus 3 plus 2? Minus 3 plus 1, sorry? Negative 2. Negative 2 squared? Positive 4. So what do you notice about me choosing a value here? It's always positive. What if you chose negative 1? Negative 1? It's positive 1, so it's 1. What if you chose negative 1? 0. 0 squared? 0. So which means to say this here will always be greater than or equal to 0. Not so. So will this have a minimum or maximum value? It has a minimum value. Can you see that? It has a minimum value. And because this has to be always greater than or equal to 0, that means to say that x plus 1 all squared. If I put minus 4 on the side, I must put minus 4 on that side as well. Not so. Which means to say, this one will have a minimum value of negative 4. Can you see that? And occurs at x equals the additive inverse of this. Where did we get the 0 at? Remember, we substituted 5, negative 3, negative 1, 0. So where did 0, where was the 0? A negative 1, that's why it's a negative. Okay, let's look at number 2. So we look at this here. So x minus 3 squared will always be greater than or equal to 0. Not so. So if I put a 2 in front there, it's still the same thing. Okay? So what happens now with this plus 5? We have add 5 on that side. We'll add 5 on this side. Now will this graph have a minimum or maximum? A minimum value. A minimum value of 5 and occurs at x is equal to 3 and so on. That's how the textbook explains. Otherwise, I just use the graph itself. Because we know that if this is positive, is the graph smiling or frowning? Smiling. Now this is also known as a turning point format, where the turning point occurs at the P and Q value. Can you see that? So your P value is If this is positive 1, this is going to be negative 1 and negative 4. Can you see that, people? So this graph has a minimum value of negative 4 and occurs at x is equal to negative. Will you guys understand? This is the next one. Number 2. Minimum or maximum? Minimum. Graph is smiling, it's positive. What's the coordinates of the starting point? 3 and 5. So what do we say? This graph has a minimum value of 5 and occurs at x is equal to 3. Okay. And of course, number 3, this graph will have a maximum. Why? Because it's now negative. And it occurs at which coordinates? Negative 2 and 3. So this graph has a maximum value of 3 and occurs at x is equal to negative. Do you guys understand? Any confusion there? No? Look at the last 2. We did it on Friday, yes my girl. For those of you realizing it now only. Yes? But because we had load shedding. Okay? Just reading the recording. Right, number 4. Minimum or maximum? Maximum. What's the coordinates of this maximum? 4 and negative 6. Remember the x is always the additive inverse while the y is what it is there. The sign only changes on the x. And when we draw these graphs and the shifting of the graph, we'll understand why. Okay? But for now it's the additive inverse. So this graph has a maximum value of negative 6 and occurs at x equal to number 5, the last one. Minimum or maximum? Minimum. A minimum value, or the coordinates of the minimum graph is negative 7 and negative 8. So this graph has a minimum value of negative 8 and occurs at x is equal to. Right, you all understand. And with that, you guys have concluded exercise 2.5 already. Not so? Is there any problems with that exercise? Okay. The full lesson can be found in the description box below.